So this video will go over integration factors to solve differential equations. So what is an integration factor? Well, essentially an integration factor is just a method or a tool that's used to solve differential equations of a certain form. So the form of differential equations when you use an integration factor is following. So it starts with dy dx plus p, which is some function of x, multiplied by y, is equal to q, where q is another function of x. So you use integration factor when your differential equation is in this form. And if it's not in this form, then we have to get it to that form. And in that case, the solution to the differential equation will be mu, which is equal to e to the integral of p dx, where p comes from the form. So the solution is mu times y is equal to the integral of mu times q, which comes from our original form, dx. So let's do a problem and we'll use this form as we're solving it. Okay, so our question is find the general solution of y prime minus y over x is equal to x minus 3 over x cubed. Okay, so the first thing we have to do to use integration factor is get it into this form. So y prime, well, that's the same as dy dx, so let's write it like that. So dy dx. Now, in the standard form, we want plus some p, which is a function of x, multiplied by y. So we can really just separate this out and say, well, this is still equal to plus 1 over x, it should be minus 1 over x, multiplied by y. So now you can see this right here in the parentheses. This is going to be the p. And on the right side, the q is just some function of x. And this is all function of x, so that's all okay. X minus 3 divided by x cubed. So this here will be our q. All right, so now we have it set up. Once you have your p and your q, the next thing we want to do is find this mu. So mu is equal to e to the integral of p dx. So let's do a little aside here. Okay, so mu is equal to e to the integral of p dx. So in this case, our p from our equation in standard form is going to be minus 1 over x. Minus 1 over x dx. Well, the integral of this is going to be, and this integral is all an exponent here. So the integral of negative 1 over x is minus ln x. And then we can further simplify this. So minus ln x is equal to e to the ln x to the minus 1. And then the e's and the natural log will cancel out to be just 1. So what we're left with here is just mu is equal to x to the minus 1, which is equal to 1 over x. Okay. So we've solved our mu, and we have our p and our q. So the next step is just to put it into the solution here. So the solution, mu times y. So mu times y. So mu in this case is 1 over x times y is equal to the integral of mu times q times dx. So the integral of mu, which is 1 over x, times q, which is from the standard form here, so x minus 3 over x cubed dx. And from here, it's more or less just a calculus problem. So let's work through this. So keep this on the left side, and then multiplying the 1 over x in. So this becomes 1 1 over x times x becomes 1, and then this becomes minus 3 divided by x to the 4th dx. Okay, so now we can integrate these individually. So integrate 1. So the integral of 1 is x, and the integral of 3 divided by x to the 4th, well, that will be plus 1 over x cubed. And then we still need to add on the integration constant c. And we're almost done. The last step is to get the left side in the form of just y. So this case will be y. Multiplying x to the other side will be x squared plus x divided by x cubed is just 1 over x squared plus x times c. And that is the final answer. So just trying to get the final answer in a form of y is equal to some function of x.